Exercise 1.3 sums 8 to 18. Okay, right. Now find the range of the function 1 by 2 cos x minus 1. Right? Range means you have to find the value of y. That means what values this function give. What are the values this function gives? Okay, so that's what we are going to do. First we have to find the value of cos x. So cos x belongs to the interval, that is closed interval of minus 1 comma 1. Okay, this is the value. So this you will learn in trigonometry in detail why we are using this value. For time being you memorize. And now cos x is greater than minus 1 and cos x is less than 1. Okay, you know that this can be written in this way. Okay, so it is written accordingly. Now I have to find 2 cos x because here I have 2 cos x. So this inequality is multiplied by 2 cos x. Sorry, 2. So minus 1 into 2. Can you understand? This complete inequality will be multiplied by minus 2. So minus 1 into 2 less than or equal to 2 cos x less than or equal to 1 into 2. Can you understand? So this is minus 2 less than or equal to 2 cos x less than or equal to 2. Now I have got a minus 1 here. So this inequality is supposed to be subtracted by 1. So minus 1. So next step. So 2 minus 2 minus 1, 2 cos x minus 1, 2 minus 1. So we'll get minus 3 less than or equal to 2 cos x minus 1 less than or equal to 1. Now the actual function is 1 by 2 cos x minus 1. So we have to take reciprocal. So when you take reciprocal, what will happen? Inequality changes. So less than or equal to here becomes greater than or equal to, here also the same. So minus 3 becomes 1 by minus 3 and here 1 becomes 1 by 1. Now again we have to write in the format like less than and less than. So this value will come here and this value goes there. So 1 is less than or equal to 1 by 2 cos x minus 1 less than or equal to minus 1 by 3. Okay, so this can be split into 2 parts. Okay, this particular part and this particular part. So that's what I have written here. So from the final conclusion we have got this function is less than minus 1 by 3. So less than minus 1 by 3 means negative value and also it is greater than 1. So 2 sets of interval we have got. So the range is less than minus 1 by 3. It means minus infinity comma 1 by 3 and also there it is greater than 1 means it is 1 comma infinity. So you have to combine the two, so union is given. So this is the range. And next problem, show that the relation y is equal to minus 2 is a function for a suitable domain. Find the domain and the range. So xy is equal to minus 2. So this can be a function for the suitable domain. So I can write this as y is equal to minus 2 by x, isn't it? Bringing the x to the denominator. So providing x is not equal to 0. Because if I put x is equal to 0, I won't be getting a y value. So if I don't get a y value, it is not a function. So this is the actual way. So y is equal to minus 2 by x, providing x is equal to x is not equal to 0, it is a function. Now we have got that x must not be equal to 0. So you can simply say I can substitute any value other than x. So the domain is real number minus set of 0. And also you cannot make the range also 0, isn't it? 2 minus 2 divided by any number, you won't be getting y is equal to 0. So range is also r minus set of 0. Sum number 10. If f comma g is a real r to r function, it is given that f of x is modulus of x plus x and g of x is modulus of x minus x. So you have to find g of f and f of g. Composition function you already know. So first I will explain what is modulus of x, which is previously learned. So minus x and plus x, two part we have, providing x is less than 0, providing x is greater than 0. Okay, now we will write f of x. So f of x function, in the place of modulus of x, I can write minus x and also plus x. Then this plus x is written as it is. So two parts. So minus x plus x is 0, x plus x is 2x, providing x is greater than 0 and x is less than 0 and x is greater than or equal to 0. Okay, the same manner we have to find g of x also. So g of x here also, in the place of modulus of x I have written minus x, and this minus x is written, and second condition is plus x. So plus x, again this minus x is written, so I have got minus 2x 0. Okay, now we have to find the composition, which is g of f of x. G of f into x is g of f of x. So in the place of x I have to substitute f of x. So g into what is f of x? 0. So g of 0. So what is, again there is one more f of x which is 2x, so that also to be written. Now here g of 0, what is x value? G of x. So in the place of x I have to substitute 0. So here I have to substitute 0. So it is minus 2 into 0. And secondly, already this is 0. Whatever, even if you substitute 2x or whatever value, it is 0 only. So x is less than 0 is also 0, greater than 0 is also 0. So finally we have got 0. The same way, f of g into x is f of g of x. So here f of minus 2 and 2x and f of 0. So the same way, when you substitute minus 2x here, it is 0 only, and 0 in the place of 2, I mean the x means 2 into 0. So finally the answer is 0 here also. So from this we can say that g of f of x is equal to f of g of x. Sum number 11. F comma g comma h is a real valid function on R. We have to prove that f plus g of h is equal to f of h plus g of h, and also we have to say what about f of g plus h. Justify the answer. Okay, so f plus g of h into x. So this can be written as just like bringing this of h with f and of h with g. So f of h plus g of h into x. So bringing x inside, it is f of h into x and g of h into x. So leaving the x, we can say that f plus g of h is equal to f of h plus g of h. Keep this as equation 1. Then secondly, we have to find this part, isn't it? So that is also written with the x. So here the f of g should be brought inside. So f of g plus f of h into x. So f of g into x and f of h into x. So from that, leaving x on both sides, we can say that f of g plus x, g plus h is equal to f of g plus f of h. Consider this as equation 2. So from 1 and 2, we can say that both are not same. So this is the justification. And sum number 12. So R to R is a function where f of x is equal to 3 minus 5. Prove that f is a bijection, and if it is, and find its inverse. It's a very important problem. So we have to prove a function is a bijection, we have to find f of g and g of f. If f of g is equal to identity function of y and identity function of x, we can say that f is bijection. So that's what we are going to do here. So first I am going to find, I'm just going to replace the function, that is it is f of x is already given. No, we have to find g of x. For that, take the question. And you know that f of x is nothing but it is y, isn't it? So y is written. Now I have to write this function in x form. So I have to take the 5 to the other side. Okay, so take this 5 to the other side. So it becomes y plus 5 is equal to 3. X, bring this 3 to the denominator. So x is equal to y plus 5 by 3. Now this x can be written as g of y. Okay, because this function has y value, so we can write it as g of y. So f of y, x we have got, g of y also we have got. Now we have to find the composition function, which is f of g into y, which is f of g of y, which is equal to f of, so g of y is what? This value, which is written inside. Now in the x place, f of x is 3x minus 5. So in the place of x, I have to substitute this value. So it is 3 into y plus 5 by 3 minus 5. This 3 and 3 cancel. So I have got y minus 5, y plus 5 minus 5, 5 and 5 cancel, it is y. The same manner, g of f of x is equal to g of f of x. So g of this 3x minus 5 is written. So in the g function, in the place of y, I have to substitute this 3x minus 5. So 3x minus 5 by 5 divided by 5. We have 5 and 5 cancel and 3 and 3 cancel, we have got x. So f of g is equal to identity function of y and g of f is equal to identity function of x. So f is a bijection. It means bijection means both are inverses to each other. F is the inverse to g, g is the inverse of f. In the question you are asked to find the inverse of f. So g is the inverse of f, isn't it? So you know what is g function? This is the g function. So simply you can write g of y as f inverse of y. But f function we have x. So replace in the f inverse of y. In the y should be replaced as x. So replacing all y by x, we have got f inverse of x is equal to x plus 5 by 3. Sum number 13. The weight of a muscle of a man is a function of his body weight of x, can be expressed as w of x is equal to 0.53 into x. Determine the domain of the function. Okay, so this w of x is the weight of the muscle of the man. So this x is the weight of the that means body weight. Okay, so what x value can be put? See, we can put any value, but very important thing is body weight cannot be negative, isn't it? So you know that body weight cannot be negative, so you cannot substitute any negative value. So all of these values are possible. So value is nothing but domain is x greater than 0. Sum number 14. A distance of an object falling is a function of time and can be expressed like this. So object is falling, okay. So that is given in a function that s of t is equal to minus 16 into t square. You have to graph the function. So I have given the graph on the right hand side. Now we have, once you graph it, you determine whether it is a one-to-one function, right? So before graphing it, you must consider one point, that time cannot be negative, isn't it? So starting time can be 0 and the object maybe reach the ground or whatever it might be to some positive number, cannot be negative. So time cannot be negative, so t must be greater than or equal to 0. So I am just plotting the table. So x is taken as 0. So in the y value, in the place of t, if I substitute 0 means minus 16 into 0 is 0. Secondly, x is 1. So 1 square is 1. So minus 16 into 1 is minus 16. Then x is 2, 2 square is 4, minus 16 into 4 is 64. Now I am going to plot it in the graph. So I have plotted. See, first point is 0, 0, isn't it? So this is 0, 0, and next point is 1, minus 16, isn't it? So maybe you will get it here, and the last one is at the bottom. Okay, so it's just like a parabola. Okay, a half parabola. Since the time must be positive, it is a half parabola. Now we have to check with the horizontal test. What a horizontal test says means, for all y in the range, the horizontal line through y meets the curve at only one point. Then the function is one-to-one function. Okay, I will show with animation that I will bring a line from the top to bottom. That line intersects or meets the curve, that is the red curve. This red curve at only one point. So it means if it meets at only one point in all the values, this is a one-to-one function. Now see, I'll show that. See this particular line from the top to bottom. It's moving from the top to bottom. It is just intersecting at only one point in the red curve, isn't it? Again, I'll show you. See, this is meeting at only one point in the x value. Sorry, in the y value. So it means it is a one-to-one function. Sum number 15, the total cost of an airfare. Okay, if you go by aeroplane or something, so they are making the ticket cost, isn't it? So just comprising the base cost and the fuel charge in rupees. And this is the base cost function and this is the fuel charge function. You have to find the total cost of the ticket and also the airfare for 1600 miles. So first it is given the total cost, I am taken as T of M as total cost. So it is given that total cost is nothing but base cost and the surcharges, I mean the fuel surcharges. So what is the base cost? This is the function, so it is written, and for S of M it is given, it is written. So when you add these two values, I have got 0.43 M plus 50. So this is the function for the total cost of the ticket. Now we have to find mileage. When mileage is 1600, what is the cost? So in the place of M, I have to substitute 1600. So T of 1600 is equal to 0.43 into 1600 plus 50. So multiplying, we have got 688 plus 50. So rupees 738 is the answer. Sum number 16. A salesperson whose annual earning is given. So this is the annual earning of the person, and secondly, this is the annual earning. This is the annual earning of the son, S of X, his son. Okay. So based on that, X is rupee value merchandise he sells. Okay. So first we have to find the total family income. Total family income is also given, A plus S into X. So A plus S into X can be taken as A of X plus S of X. What is A of X? It is already given in the question. This is A of X and this is S of X. So I have written that. So adding 30,000 with 25,000, I have got 55,000, and 0.04x plus 0.05x is 0.9x. So this is the function for the total family income. Now taking X value was 1 crore and 50 lakhs. Okay, taking the X as 1 crore and 50 lakhs, we have to find the family income. So in the place of X, can you understand? In the place of X, I have substituted here the value 1 crore 50 lakhs. So here also I have to substitute the same. So multiplying this, I have got 55,000 plus 13 lakhs and 50,000. So adding these two, finally this is the answer, 14 lakhs and 5,000. Sum number 17. The function for exchanging American dollars is given as function f of x, where x is American dollars, and the same way to convert the Singapore dollars to Indian dollars, this is the function. Okay, right. Now here the y value is nothing but it is Singapore dollars. Now we have to find exchange of American dollars to Indian dollars. I'll represent in a pictorial form. See, American dollars to Singapore dollar is this function. Singapore dollar to Indian dollar is this function. You are asked to find American dollar to Indian dollar. Can you understand? American dollar to Indian dollar. It means a composition function. So it is nothing but what? G of f. So to convert American dollars to Indian dollars, it is nothing but G of f of x. So G of f of x, you know that. G of what is f of x? F of x is 1.23x. So that is written. In the place of y, I have to substitute 1.23 into x. So which is equal to 50.50 into 1.23x. So multiplying, I have got 62.115x. Okay. Now the last problem, the owner of the small restaurant, okay, he is preparing a meal. So this is the cost price of the meal, which is 100. So the menu price, selling price is x. Okay. So number of customers coming for that particular evening is given in a function that d of x is equal to 200 minus x. We have to find the total revenue. That means the total sales amount of the day and total cost, the amount he has spent for the particular evening to prepare the meal, and the profit we have to find. That should be written in the form of function of x. Okay. Now see, day revenue. So revenue I have written as r of x. Revenue means the total sales amount. So number of customers into menu price. Okay. So number of customer function is nothing but d of x, which is this I have written here. What is the menu price? Menu price is x. So into x. So 200x minus x square. Next one is total cost. Total cost can be written as t of x. So number of customers into actual cost, isn't it? So number of customers, you know that 200 minus x into 100. What is the actual cost? 100, isn't it? This is the actual cost, 100. So that is given here. So multiplying that, I have got 20,000 minus 100x. Now the profit. What is the profit? The total sales minus the amount we have spent, that is Rx minus Dx. So Rx function is 200x minus x square minus 20,000 minus 100x. So bringing the minus inside, 200x minus x square minus 20,000 plus 100x. So adding the 100x and 200x, I have got 300x minus x square minus 20,000 in rupees. So that's all. We have completed the exercise 1.3. I think two problems, that is sum number 19 and 20 is left. So that two problem is left as homework. So do as home assignment, and that's all. Thank you.